Hi, everybody. You're going to hear my dog and squeaking the toy in the background, so my apologies. So we're looking at number 38, and there's going to be an answer, but there's also going to be some extra stuff that I throw in here. So first of all, the answer to the question is the base function is x squared. What does all of this mean? So we've got to put this into vertex form. And I'm just going to tell you that it's going to be a vertical shift down 3 units. It'll be a vertical stretch by 3, by a multiplier of 3. And then there'll be a horizontal shift of 1 unit left. Okay. So what I'm about to do is just a process. It's completing the square. And the first thing you need to do is you need to make sure that the coefficient for the x squared is 1. Okay. And you're really only doing this temporarily. There's a couple ways to do this, and I think that the way I'm doing this is most easily explained. So I have this 3, so I'm going to divide every term, distribute it to every one of the terms. And so what ends up happening is I'll have a 3 here, I'll have a 3 here, I'll have a 3 here. These cancel, leaving me with a coefficient of 1. And this will reduce down to 2. Now, the next step is actually to generate the parking lots. So you're going to have f of x over 3 plus the parking lot is equal to x squared plus 2x plus the parking lot. Now, how did I get these 1s? And this is the completing the square process. What you do is you take the coefficient that is attached to the x to the first power. And let me just pause for a second. So if this was 4, this would be 2. You'd use the coefficient of the 2. If this was 6 and this was 3, you'd use the coefficient of the 3. So you use the coefficient of quote-unquote the middle term, or the term that has the exponent that's half of the lead exponent. Now let me scroll down a little farther. So if I take 1/2 of 2, which this is just the process, so I take half of that number and I get 1. And I take this number, whatever this number is, and I square it. I put it in each one of the parking lots. Now, this piece right here is a perfect square trinomial. And what it will do every time is it will be x, and because this is positive, it's always this value. It's plus 1, so it's x plus 1, and then it's squared. Now notice we added 1 on this side. Okay, so it's important that you see that you have this 1 here as well. Now what we're going to do is we're going to undo some of the work that we did up above. We're going to solve for this f of x. So we're going to subtract 1 on both sides. And so we're going to have f of x is equal to, and they'll read x plus 1, the quantity squared, and then minus 1. Now this denominator I need to get rid of. So I'm going to multiply both sides by 3. You'll notice that I put this in parentheses. And then I am going to distribute it to both terms inside. So it's 3 times the quantity x plus 1 squared minus 3. Okay, so real quick, let me go back. I said that it's a vertical shift down by 3 units. That's what this part is. It's a vertical stretch by a multiplier of 3. That's what this is doing. And it's a horizontal shift 1 unit to the left. That's what this part's doing. The question is, one of the other questions is, what about the range? Well, this opens up because it's positive. And range is the y values. And so if our vertex is the ordered pair, -1, -3. Now remember, it's HK, and it comes out as the opposite of this. So it's -1, -3. Since this opens up, our y values are going up. So our range is y is greater than or equal to -3. It's this value. If it opened down, then you would just say y is less than or equal to that value. Okay, now, let me scoot back over here. The answer is up over there, but this is just some extra stuff. Okay, so it does open up, and the reason that it opens up is because that's a positive. The a is a positive. Okay, the y-intercept. Well, what we do is whoops, hold on. Remember, and I should, that's a different note, hold on. So to do the y-intercept, remember you let x be equal to 0, right? So you can plug in the 0, and you've got 0 and then a 0, so you're left with this 0. Or, because we're in the alternate form, we can think about it as O comma C. And C is 0. That's where that's coming from. Now, to get the x-intercepts, I hope I said y-intercepts earlier, but to get the x-intercepts, there's two ways you can do it. Remember, you set it equal to 0. You let the y be 0, and you either can factor it, which is here, or you can use the quadratic, where your a is 3, your b is 6, and your c is 0. And you can pause the video and see the work right here, or pause the video and see the work right here. And what you end up with is two x-intercepts, 0, 0, and -2, 0. The y-intercept and the x-intercept are the same things. So just as a refresher, this is just bonus stuff down here. This is the actual answer to the problem. Okay, hopefully that helps.